Hello dear students. This time we are meeting again. I want to discuss with you this reducible exact differential equations. This is lecture number 4. So whosoever from you wants to go to lecture 4, it is my suggestion that you should first go to lecture number 1, 2, 3 and then 4. Actually, I want to just recap or recapitulate so that you will have a grasp on this lecture. What we did previously. Previously we discussed with you the different rules for finding out the integrating factor. You know the integrating factors we need actually to transform a differential equation of the form m dx plus n dy is equal to 0. It is the first order linear differential equation which is not exact. If it is not exact, then how we proceed? I have told you before this three rules we have done. Number 1 was the homogeneous rule. When m dx plus n dy is equal to 0 is a homogeneous, then how we find out it is integrating factor. Second was when you can write the differential equation like this. You have y out, inside you can write some function of xy, then dx, then plus some function of x into this x out, then some function of say phi to f2 xy into dy is equal to 0. If you can write the differential equation of this form, it is rule number 2. You know we have the integrating factor. It is 1 upon del m by del y, this mx minus ny in this case. Then we had rule number 3. If first two forms do not occur, that differential equation is not homogeneous or it is not this form, then we find out what partial derivative of m with respect to y, partial derivative of n with respect to x. And in rule number 3 I said we subtract del m by del y minus del n by del x division by n. If that becomes the function of x alone or even constant, then we take the integrating factor e raised power integral of m. It is just to recapture so that you will have a grasp on this rule. It is actually I am stating with rule 4th, and this is rule 4th. This will state if m dx plus n dy is equal to 0 is not exact. It is not exact, but at the same time you are observing, and if partial of n by n with respect to x minus partial of m with respect to y division by, here I will take m. You see, in rule number 3 we took partial of m with respect to y minus partial of n with respect to x division by this n. Here we do partial of n with respect to x minus partial of m with respect to y minus m. You can remember this way, n minus m by m. Here m minus m by n. This is how to remember. If this comes out to be, if this function is function, if this turns out to be function of y alone, I mean if this expression, when you evaluate this expression, you can have just a glance over this. You can easily see is this function of x or function of y. If this comes out to be del n by del x minus del m by del y by m is a function of y alone, say it is some function of y, psi of y, then what is integrating factor? Then integrating factor is e raised power integral of psi of y dy. This is the integrating factor. We evaluate this integral with respect to y and multiply both sides by this integrating factor to this differential equation, and you will see that in this case it comes out to be exact, then we solve it as usual. On the basis of this, let me have some application. I will take some application on this rule. So we have so far discussed with you four rules. Let me take some application here. I will take a question from book. You can have the different books at your disposal. Let me take some typical question. Suppose you have to solve the differential equation. It is 3x square y4 plus 2xy dx, then plus twice x cube y cube twice x cube y cube minus x square dy is equal to 0. It is 3x square y4 plus 2xy dx plus 2x cube y cube minus x square dy is equal to 0. I have taken such question. Let me see what happens to this. As usual, you know what is this your? It is your m. This is your n. It is m dx plus n dy. I will find out here what is partial of m with respect to y. You see here partial of m with respect to y. It is 12 x square y cube plus 2x. Differentiate this with respect to y. It is 12x square y cube plus 2x. Differentiate this. It is your n. Partial of n with respect to x as you do. It will be 12 x square y cube minus 2x with respect to x. It will be sorry, it is 3 2s are 6 x square y cube minus 2x. Let us see what is. Sometimes you have to go this way, del m by del y minus del n by del x by this n. If that comes out to be alone function of x, you will go. Now if you find out this minus this, you see what about now partial of n with respect to x minus partial of m with respect to y by m. Let us see what is this. It is your 6x square y cube minus 2x, then minus 12 x square y cube plus 2x by what is your m? It is 12 x square y cube sorry, your m is this. It is 3 x square y4 plus 2xy. Let us see what this comes out to be when you find out it. This is 6x square y cube. It is minus 12 x square y cube. It will be minus 6 x square y cube. Minus 6 x square y cube. This is your minus 2x. This is again minus 2x. You will say it is minus 4x by 3 x square y4 plus 2xy. Okay, let us see what is this. You can take common here. Let me take I can take minus 2x common. Minus 2x in the numerator. From numerator I can take. This will be 3. When you take 2x, it is 3x y square, then plus 2 only, plus 2, and you see from denominator what we can take x. We can take xy in fact common. Xy we can take common. When you take xy common, it is 3xy cube. 3xy, here it is also y cube, sorry. It is 3xy cube and it is plus 2. Just to look again. I have found out this. Then I want to see what about del n by del x minus del m by del by m. This is this, the value of m. This comes out this, take minus 2x common, it is 3xy cube, and this is plus 2 because minus 2x is out, and here we took xy common, so it is 3xy cube plus 2 plus 2. You see, this comes out to be same, and x goes. What is this now? This is equal to minus 2 by y. It is minus 2 by y. So this fraction comes out to be partial of n with respect to x minus partial of m with respect to y by m is minus 2 by y. What is this now? It is function of y alone. So rule number 4 is satisfied in this question. So you see, sometimes you find out if first two rules do not satisfy, that is, you don't have the partial differential of homogeneous, you cannot have y out in first term and x second term. If that two previous rules do not satisfy, they are not of that form, then you find out this way. If you write here del m by del y minus del n by del x, you have to write here n. This should be function of x alone. And this is the fourth rule. And I have come out this the function of what? Y alone. So what will be the integrating factor as per our this rule? Well, I need this here. I will not rub it. Let it be there. So according to rule number 4, what is integrating factor? So integrating factor is now, it is e raised to power integral of minus 2 by y dy. It is your integrating factor. What is this? This is e raised power minus 2 integral of 1 by y dy. This is e raised power minus 2 log y. And this comes to be e raised power log of y raised power minus 2. That is y raised power minus 2 only. Because you know e raised power log of m to the base e is what? M. So it is y raised power minus 2. So integrating factor is 1 by y square. This is your integrating factor. What we do is we multiply both sides of first by this integrating factor. Now let us multiply. We multiply equation first by integrating factor. You see, what is this now? This is your 3x square y4 by y square plus 2xy by y square. I am multiplying by this 1 by y square into dx plus this is your 2x cube y cube, 2x cube y cube by y square minus x square by y square, x square by y square dy is equal to 0. Let us simplify this. What is this now? This will be 3x square, this is y square, this is 2x by y, this is dx, this is your 2x cube y, 2x cube y, this is minus x square by y square dy. This is the transformed equation. This is the transformed equation. This is now my m dash. What is m dash? M dash is 3x square y square plus 2x by y. This I will denote by n dash. N dash is 2x cube y minus x square by y square. Let us find out partial derivative of m dash with respect to y. What this comes out be? This is 3 to the 6x square y, then derivative of 1 by, it is minus 2x by y square. Here partial derivative of n dash with respect to x. What is that? It is 6x square y minus, we are differentiating with respect, it is 2x by y square. you have got here partial of m dash with respect to y is 6x square y minus 2x y by y square. Here you have got partial of n dash with respect to x, it is 6x square by y minus 2x by y square. So what we have got? So we have got that partial of m dash by y is equal to dou of n dash by x, implies equation number second is now exact. The transformed equation comes out to be exact. This is exact. When it is exact, so what is solution? So this implies it is solution is m dash dx plus integral of n dash dy is equal to c. What is here? Here we treat y as constant. Here we terms n involves n dash involves terms which are free from n dash from x in n dash. Okay, here we write those terms which are free from x in n dash. Write down that. What will be the integral? This will be your integral of, yes, this is your m dash is 3 x square y square, then plus 2x by y dx plus integral of, from n dash you take those terms which do not involve x. This is n dash, this involves x, this involves x, so we don't get here anything, it is c. So your solution will be integral with respect to x, it is 3x cube y square by 3 plus 2 by y x square by 2, it is the integral of x with respect to x is equal to c. So it is x cube y square plus x square by y is equal to c. This is the solution of this differential equation, which was not exact, but we could write it partial of m with respect to n minus partial of n with respect to x minus m with y by m as what? Function of this y alone. Let us have one more example. We have done many questions on this. Let us have one more question here. Suppose we have to solve the differential equation. Let me take a question here like this, of this same pattern, which pertains to rule number 3 and 4th here. Rule number 3 and 4th. Let me see which one I can take. Okay, let me take this one. Solve x square plus y square plus x into dx plus x square plus y square plus x dx plus xy dy. This is the question. You see, this is the question. You cannot apply here variable separable method. If this term would have not been here x, then it was a homogeneous. X square, y square, xy, then it was a homogeneous. So it is neither homogeneous, nor can we separate the variables. Okay, and even we cannot write it in the form of dy by dx plus py is equal to q. So we have to go on exact test. Let me see if I treat this as m, this as n as usual. What is partial derivative of m with respect to y? We take first. It is 2y. Here I have to take partial derivative of n, this is n, with respect to x. With respect to x, it is y. Okay, so del m by del y is not equal to del n by del x. So not exact. Not exact. So we have to go now for what? Integrating factor. Integrating factor. Let us see, is first rule applicable? Is first rule applicable? Which says homogeneous? No. This is second. This is second. This is here second degree, but this is not. So first rule for finding out the integrating factor fails. Remember, go to first rule, go to previous lecture, see there what is the first rule for finding out integrating factor. Then we have second is not possible. Then we may have to switch on third and fourth. Third and fourth we'll get it from here. You see, if I write here what is del m by del y minus dou n by dou x by then n, this should be a function of x. If it is not, then I will see what is this minus this by m, this minus this by m. Let us see here, del m by del y, it is 2y, okay, minus y by what is your n? N is your xy. This comes to be y by xy. This is 1 by x. Oh yes, rule is applicable. It is a function of x. This is function of x. I will mention for your clarity, for your just to you will grasp up the rule number third. This is by rule third. Rule third is applicable here. Rule fourth you did. It is rule fourth. So what is integrating factor? So integrating factor in this case is e raised power integral of 1 by x dx. That is e raised to power log x. What is this? Log of x to the base e raised to log of x to the base e. It is only x, as you know. It is the integrating factor. So we have to multiply first by x. That is integrating factor. So that must reduce to reduce to exact, because we are doing what? Some questions on a reducible form, when we have to reduce the differential equation to this form. Okay, when we multiply this by x, you see what happens. Multiply this by x, it is the integrating factor. This comes out to be x cube plus xy square plus x square dx plus x square y dy is equal to 0. This is now equation number second. This is the equation which is a reduced equation. It is a transformed equation by the integrating factor. Let me see, is now this exact? Is this exact or not? For that, I have already told you, I will now change this. I will name this m dash, this by n dash, because if I again use m, you may get confused, because we have used the m for this, n for this. There is no ambiguity, no disturbance if you take this by m dash. M dash we take x cube plus xy square plus x square. This is partial of m dash with respect to y we have to take. This is your 2xy. Then you have n dash. What is n dash? It is x square y. Here you have to take partial of n dash with respect to x. This is y, this is x. It is again 2xy. So you will say yes, equation number second is now exact. Equation number second is exact. The transformed equation is exact. It actually worked here. What? Rule number third worked here. So when it is exact, what is solution? Solution will be integral of m dash dx plus integral of n dash dy is equal to c. As usual, how we proceed? In m dash we write all the terms of m, but treat y constant. It is integral of m dash. What is this? It is x cube plus xy square plus x square with respect to x, treating y as constant. In n dash we write those terms which do not involve x. This is your n dash, but only one term, it involves x. So write it 0 or omit it, is equal to c. So this is integral of, it is x4 by 4 with respect to x. This is constant. This is x square y square by 2. This is plus x cube by what? X cube by 3. X cube by 3 is equal to c. You can multiply y, you can take 12 LCM, multiply third by 12. You can write it as 3x4 plus 6x square y square plus 4x cube is equal to 12c, which is again c. 12c is arbitrary constant. So this is what? This is the solution of the differential equation. This was well, in my previous lectures on exact differential equations, some student he says he is perhaps from somewhere doing integrated course somewhere. Some student has make a comment on my this YouTube channel. He says, what is the procedure for integrating inverse function? Actually, I have already told you the lectures that we are delivering here on this process. These are actually on not on 12th class. These are the lectures I have already told you for UG, undergraduate classes, and BTech classes. Okay, undergraduate and BTech, so a bit higher, but not 12th classes. If we switch back, how we integrate the inverse functions, there we do it in 12th class, and there are many questions that you do it there by this method that is known as integrating by parts. You can have the integration of inverse functions integrating by parts. I can share the rule here, no problem. I can share the rule, but this is the something that we are doing for higher class here, not for 12th better. So he wanted to ask me how to integrate. For example, this is the answer to your query. Answer to your query that you have asked me. Integrate, how to integrate inverse t functions. In fact, there are many methods. When you go higher and higher, you can write the this expansion for any function, whether it is sine x, whether it is cos x, whether it is sine inverse x. You can write the expansion of that, then integrate. Becomes very easy once you know its expansion, but you cannot remember all the expansions. So better is to switch on that 12th class rule. I will give you the rule here. Suppose I have to integrate. My question is, suppose I want to integrate sine inverse x dx. This is how to integrate the inverse functions. I can write this as integral of 1 sine inverse dx. I will integrate by parts. Integrate by parts rule. You know, I will just review what you have done in your previous class. This is just integral of u v dx. U sometimes we say first function, and v we say it is the function, second function. Actually, we take u that function which we can easily, whose derivative leads to constant, and v that whose integral we know. This is one thing. And in lower classes, you might have heard about the rule that is ILATE. ILATE. I stands for inverse function, L for logarithm function, function, and T for trigonometric, A for algebraic, E for exponential. Whatever comes first of this ILATE, that we take as u. Actually, if you apply that method here, this is your inverse trigonometric, sine inverse. This is your algebraic. So if I write ILATE according to your rule, but that is not a generalized. ILATE which we apply in class 12th, it is not generalized. Why it is not generalized? Suppose sometimes you have to integrate the function like this: sine x raised power n minus 2 into cos x dx. Here we also apply what? Here also we apply by parts rule, but that method which you did in your class 12th, it is not applicable here. You have to see what we can take for different. Naturally this, because we don't know it is integration direct, we take this for differential and that for integration. So it is how you do the such questions. So here I should take inverse comes first. So I will take, what is the formula first? This is u as it is integral of v dx minus whole integral derivative of u with respect to x, integral of v with respect to x whole is to be integrated with respect to x. I have to give some question, these lectures on this 12th class Those will be on typical this topics I will discuss with you for 12th class students. Also, we are trying to make some lectures for them on the same channel. 12th class, we will be discussing there with the details how we differentiate, how we integrate, and some concepts which you have to use in classes after 12th, in engineering, in higher classes, in integrated courses, extra. There you have the main use of differentiation and integration. Once you have the differentiation concept very clear, integration concept very clear, then you can grasp the things that go in higher classes. Okay, in any way, this I was saying that if we integrate this sine inverse, we write this one, this is our inverse, we treat this as algebraic function because constant is also algebra. So what I do, I take u is equal to sine inverse x because it comes first, and v I will take 1 and use this method. I will write again. What does this says? U as it is, okay, integral of v dx minus whole integral differentiation of u with respect to x into integral of v dx whole is to be integrated with respect to x. It has also its own logic. Why we take u as sine inverse x? The logic is I cannot take this for integration. If I would take sine inverse for integration, that means I am knowing what is the integral of sine inverse x direct. So what is the fun of writing this formula? So when I don't know it is integral direct, I don't know it what is its integral, so I should take it for differentiation. So I took it for differentiation. So second function is product, because in case of the integration by parts we must have at least product of 2 functions, then we write integration by parts. Even we can integrate by parts by 3 functions. We have done, you might have done in your class 12th. Okay, let me apply this here. Your u is sine inverse x, integral of 1, it is x, as you know, minus whole integral. Now differentiation of sine inverse, you know, it is 1 by under root of 1 minus x square. It is differentiation I am writing sine inverse x. Then integral of 1, it is x dx. You see how easy now it is. You can write, you can do it by substitution also, whatever you like. It is x sine inverse x minus integral of, I can write it this way also, 1 minus x square raised power minus 1 by 2 x dx. There are 2 ways. I have already told you when I have discussed it with you the basics of integration. There I said that substitution method is a very interesting, it's a fundamental tool in tackling the fundamental integral, to converting a integrand into some standard form by substitution. We can convert, suppose you have under root of a square minus x square minus a square, 1 by under root of x square minus a square, 1 by under root of a square plus x square, 1 by under root of x square minus a square. All these integrals, you can reduce this integral into standard form. You can get rid of the radical by what? By substitution. Substitution is a very interesting thing. You can here also use the substitution. You can use x sine theta or cos theta. You can just reduce this integral by substitution. But you have one more formula. It seems to be that 1 minus x square, if we differentiate 1 minus x square, it comes out to be minus 2x. So I can convert this minus 2x. I can write it, there is one more method, x sine inverse x. I will write it here. I will write it plus I will write 1 by 2 integral of, because I need here 2, and minus 1 minus x square raised power minus 1 by 2. It is your minus 2x dx. Okay, this is your fx and f dash x. I have divided by 2, multiplied this by 2. This minus I took with this, because when I differentiate 1 minus x square, what is this? Minus 2x. This is your fx. This is your fx. I am just trying to make you understand for the student. He might be reading in 12th. He has posed this question. It is your minus 2x. It is fx and f dash x. So you know what is it? Fx is for n plus 1 by n plus 1. You can write it now. It is x sine inverse x plus 1 by 2 1 minus x square raised power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus c. So this comes out to be, if it is not visible here, I will go here. This comes out to be I is equal to x sine inverse x 1 by 2 cancel. It is plus under root of 1 minus x square, because this will be 1 by 2 plus c. This is how we integrate this inverse trigonometric functions. You are asking me what is the procedure. Procedure is the same what you did in your previous classes, or there is some other procedure in higher class you can tackle in future these integrals. Similarly you can do now integral of cos inverse x, even integral of tan inverse x you can do with this method. Integral of tan inverse, cot inverse. If you have somewhere, say sometimes you want to integrate like this say you have an integral like this. You have seen such problems. We are coming often such problems in class 12. Suppose we have to integrate x square tan inverse x dx. You can also do. You will take this for differentiation, this for integration, and go by parts. This will reduce, and finally you will reach some where you can make the substitution and you can do such question. This is how to integrate inverse functions, because I have just took this question in between the so actually it was our lecture was on reducible exact differential equations which are reducible to exact form, differential equations which are reducible to exact form by this fourth rule. It was rule number 4th, and it just recollect that some student had asked me what is the procedure for integrating inverse trigonometric functions. It is very simple. It is your 12th class concept. I hope you have got the answer, and we will see next. We will meet in another video. And if you want to have different these chapters from this that you are pursuing in different courses, it is better to subscribe the channel, and when you subscribe the channel you will get the topics of your own taste. Thank you very much.